This lesson is not really too long, and this is lesson 6 for the AP Calculus, and we're still part of the review. I'm just going to show you guys how piecewise functions work, how to graph them. I only got 2 examples for this, and then I think we're good. So maybe I can just put this all in just one video. Let's start. Number 1, graph the following piecewise functions. And again, piecewise, it is what that name is. We're just not taking the whole thing, but we're only taking a piece or a portion of what we want. So what I usually try to do is, my technique is I usually graph the functions fully first, and then I do what's called a graph and erase, and I erase the parts that I don't need and then keep the parts that we do need. So let's just start one by one. So notice that we have 2 different functions in one piecewise function. So we have 2 different lines, and I'm going to start with this one first, x plus 2. So we do have a slope of 1 over 1, but our y-intercept is at 2, so I'm going to start at 2 over here. And then our slope is 1 over 1, so 1 up, 1 to the right, 1 up, 1 to the right. This is one way to do it, so of course I'll just show you one way. When you get better at this, I think you can probably just only draw what you really need, but I'm just showing you how it's done. Okay, so that's the graph fully, and you've graphed this before. This part over here, probably not doing this red. These are what, after the comma, you know, these inequalities, these are what you can call your boundaries. Your boundaries are what we actually want from this whole, from the whole graph. Okay, so what we only want is x is greater than or equal to 0. So you're going to pick where x is at 0. So this is where x is at -8, -6, -4, -2. Bam. So this is where x is at 0, and then we go towards the function, the graph. Okay, so it's right over here. We want things that are greater than that, greater or equal to that. So then my question is, if we want things that are greater, which side are we going to keep? Are we going to keep the right side of this function from the 0, or are we going to keep the left side? We're going to keep the right side. Okay, so we're going to keep the right side, because those are the things, those are the numbers that are greater than 0. Okay, so what I'm going to do is I'm going to erase the left part, the left of 0. So all of this is gone because we don't need this part. And then I'm going to accentuate a couple things. Because it is equal to, I'm going to make this a closed dot. So I'm just going to close it like this. And I'm just going to shade it in light green over here, what we actually want. And make sure I have an arrow here because we want things that are greater than that all the way. Okay, so what I've graphed here in lime green is this function. Let me go see if I can grab another color. Yeah, I can grab. Okay, hopefully this yellow will work a little bit. Okay, so now let's do x minus 2, which is another line. We're going to start on the y-intercept of -2. And then thankfully it's the same slope. It's going to be 1 over 1. So same thing, I'm just going to draw the whole thing first. This is just my technique. I like to do it this way. Like I said, after a while when you get better at this, then you'll just probably only graph what you need. Okay. Look at your boundary though. The boundary is in between -2 and 0. So I'm going to spot where -2 is at, where x is at -2, which is over here. And then I'm going to go down to the graph. Okay, so I'm going to just have this point as a reference because we're going to need a little bit. And then it's between -2 and 0. So this is where x is at 0 and right over here. Okay, this is an in between. So we only want things that are in between these 2 numbers, -2 and 0. That means outside of it, we don't need. Since we don't need them, we're just going to erase those parts like that. I'm going to erase this part over here too. There's a reason why I'm erasing it. The reason why I'm erasing it is because now we can either fill in or make a hole. At the -2, we're going to fill in because it's less than or equal to. So this is going to be a closed dot over here. Okay. And then this is no equal sign over here. So at the 0, where x is at 0, we're going to make this an open dot. and then I'll shade in this in yellow-orange. Okay, so that is how piecewise functions work. You have the function over here. You have the function, and then you got the boundaries of what parts we need for that same function. Okay, all right. Let's now go to number 2 on this. Okay, number 2. We have 3 different functions and we only want pieces of it. So let's just start with the first one over here. Negative g of x is equal to negative 3. Remember, this is the same thing as y equals negative 3. If we have a y equals negative 3, this is going to be a horizontal line. So let's go draw that horizontal line first at the negative 3, which is hopefully over here. I'm going to draw the line fully first. Okay. But then look at our boundary. X is less than 0. So I'm going to spot where x is at 0 first. So this is where x is at 0. I'm going to go down. Okay, less than. Should we keep the right side or should we keep the left side? We are going to keep the left side because it is less than. Here are the numbers that are less than 0. Negative 2, negative 4, negative 6, negative 8. Those are less than 0. So we're going to keep the left side. We're going to erase this right side over here. And then we're going to accentuate a couple things. At the 0, there's no equal to sign. So we're going to do an open dot at the 0. And then I'm going to make a left arrow indicating we want things that are less than that. Okay, so this is done in black ink. Then I'll do the second one in lime green. Let's do this one. We got a square root function. And we've done parent graphs before. These previous 2 lessons were parent graphs. So I'm just going to do our starting point. Our start point for this one here is at, well, there's nothing by the x, so it's going to be 0, 2. So we're going to start on 0, 2. I'm just going to do this in pencil first. And there's a pattern for square root, positive square root functions. And I'm just going to say the pattern. You can always refer back to that. I think it was 2 lessons ago, a couple lessons ago. It'll be 1 to the right, 1 up, and then 4 to the right, 1, 2, 3, 4, and then 2 up. Okay. So I'm just going to draw that with the arrow. Remember, for the square roots, you don't have an arrow over here. This is the actual starting point. Okay. But look at our boundaries. We only want this function from 0 to 4. So at the 0, we're going to make a close dot. So we're going to close it. But when x is 4, which is right over here, we don't see any equal to sign. So I'm going to erase this parts here. And I'm going to make sure that when x is at 4, I am going to make an open circle right over here. Okay. All right, so this is done here. Last but not least, let us do this portion over here. And I see this is a parabola because we have a square. Let's talk about the starting position first, or the vertex for parabolas. So the start point or the vertex. Okay, opposite of what you see inside the parentheses. So it's going to be positive 6. And then we can add a plus 0 at the end for your k value, so 6, 0. So I'm going to start with that first, 6, 0. And then we need to follow the 2x squared pattern. Again, you can go back to your parent graphs a couple lessons ago. For the 2x squared pattern, you're going to go 1 to the right and 2 up from your starting point or your vertex. Go back to your starting point, you're going to go 2 to the right and then 8 up. The good thing about parabolas is you guys already know that it is a mirror reflection from the vertex, and then so we can just do like some sort of mirror action like this. Apologies, my parabola is not as nice or clean, but we can clean it up because we have to figure out where we want it from. We only want this from 4 to 8. And so where x is at 4, I'm going to close it, and because there's an equal to sign, so we're going to make a closed dot over here. And then we want things in between, so I'm just going to shade in between with my yellow-orange. And then where x is at 8, we're also going to have a closed dot because there's an equal to sign here. So that means these two arrows that are outwards, I'm going to erase that because we don't need those values. Okay. All right. Well, this is the notes only for piecewise functions. Please get to work.